Solar Energy by Karen Lechana Kenny. This is a table of contents. A table of contents allows you to go to it gives you the titles or the chapter names throughout the book. So instead of reading the whole book, if you wanted to find a certain topic, you would just go to that chapter or page. Chapter 1, Sun Power. It warms the earth so that life can thrive. It helps plants grow with its beaming rays of light. It affects the weather and lights up our days. It's also free and always turned on. What is this incredible renewable power source? The sun. Its power is solar energy. And renewable means we keep making it. It never runs out. The sun is our solar system star. It is 93 million miles, 150 million kilometers from Earth. From there, it sends out energy every second of the day. It's been doing this for 4.5 billion years. How? The sun is a hot ball of burning gases, mostly hydrogen gas. This gas fuels the sun's power at its center, the core. The sun has a strong force of gravity. Remember, gravity is what pulls objects towards the ground. Its temperature reaches 27 million degrees Fahrenheit, 15 million degrees Celsius. Pressure is also strong in the core. Both the temperature and pressure change the hydrogen gas. Its atoms join together or fuse in the core. As they fuse, they become helium gas, but they also release energy. This process is called nuclear fusion. Dun, dun, dun. The released energy moves very slowly through the sun's layers. Scientists think it takes more than 170,000 years for it to travel through the largest layer of the sun. This layer is called the radiative zone. Then the energy enters space as electromagnetic radiation. Lots of big words in here. This energy contains light, X-rays, radio waves, and more. The energy rays spread out in every direction. They hit all the planets in our solar system, including Earth. Our planet receives a small portion of this energy, just 8 minutes and 20 seconds after it leaves the sun. Solar energy's journey. Solar energy starts in the sun's core. Then it travels through the layers of the sun before it enters space. As the Earth's surface faces the sun, it receives the sun's energy. This energy keeps life on our planet going and growing. Oh, I have to sneeze. Excuse me. It warms the earth and makes air move in the atmosphere, creating weather patterns. Plants use the energy to make food and grow. Animals and people eat those plants and breathe the oxygen they make. The sun's energy can do more than keep us alive and warm the planet. We can also collect it in places that gets lots of sun. With the right technology, we can turn the sun's power into electricity. Then we can use that electricity in our homes, businesses, and communities. The sun's gravity keeps the planets in our solar system circling around it. Fact: in 1 hour, the Earth receives enough of the sun's energy to fuel the entire planet for 1 year. But right now, we can only collect about 1% of that energy to make electricity. Chapter 2, Catching Solar Energy. The Earth is constantly spinning. As it spins, the side facing the sun experiences daytime. That's when solar energy reaches that half of the planet. Not all parts of the planet receive the same amount of energy. It depends on where you are. That's because the Earth spins around on a tilt. One half of the planet is always farther away than the other half. As it moves around the sun, different parts of the Earth get more solar energy. When it's winter somewhere, that part of the planet is tilted away from the sun. When it's summer, that part is tilted towards the sun. The best places to capture solar energy receive lots of sunlight for many hours of the day. Some deserts are very hot and dry for most of the year. The Mojave Desert in the United States and the Sahara Desert in North Africa are perfect places to collect solar energy. But you don't need to live in the desert to find solar energy. Anyone can collect it on a sunny day with the right technology. There are a few different ways to catch the sunlight. Thermal energy systems. One way to collect and use solar energy is to change sunlight into heat. Thermal energy systems can do this. They use solar panels to heat homes and businesses. The panels go on a building's roof. Then, solar energy heats a liquid inside the panels. The heated liquid moves in pipes to rooms or storage tanks to heat the building. You look in this diagram, it says in thermal energy systems, rooftop panels can heat an entire building. Thermal systems can also use heat from the sun to make electricity. Solar thermal power plants collect solar energy using mirrors. The mirrors focus the energy onto a tube or a tower filled with liquid. The liquid receives this heat and gets very hot. The hot liquid turns water into steam. The steam then moves the blades of a turbine. This powers a generator that makes electricity. So here we have the diagram of it, how a solar thermal power plant works. 1. Sunlight hits mirrors that focus energy onto tubes. This heats liquid in the tubes. 2. The heated liquid boils water into steam inside a heat exchanger. This device transfers heat from one fluid to another, cooling off the first liquid. 3. The steam moves a turbine. Then a generator makes electricity that is sent into power lines. Fact: long curved mirrors can capture and focus sunlight. They make its energy 30 to 100 times stronger. They make the temperature rise up to 750 degrees Fahrenheit, which is 399 degrees Celsius. Solar cells. Another way to catch sunlight is with solar cells. They change sunlight directly into electricity. Solar cells are filled with a conducting material. Conducting means it will allow electricity to pass through it. That material allows electricity to move from one point to another. These cells are grouped together in panels. You've probably seen them on rooftops. Many panels are set up as a solar array. The arrays can cover a whole roof or be set up in rows in a field. Larger arrays catch even more sunlight. Here we see solar arrays are also called solar farms. So these are all solar cells. How solar cells work. Sunlight hits the top layer of the cells. This energy transfers to electrons. The electrons move down in the cells. Then the electrons move out of the cells into a wire. The small parts of sunlight called photons hits the top of the cells. The conducting material absorbs some of the photons. When this happens, the photons transfer energy to electrons in the conducting material. These electrons move down through the cells. Then the electrons move out of the cells into a wire. The wire carries the electrons in one direction. This movement of electrons is electricity. These kinds of technology turn sunlight into energy we can use, electricity and heat. We use this electricity and heat every day in many different ways. It can keep our homes warm and our computers running.